So we opened the registration for the conference today, right, Joel?
Yeah.
Yeah, so the next Open edX conference is happening in Madrid, which is in Europe, which should be exciting. It's May 24th and 25th, which is a Wednesday and a Thursday of that week. So I'm going to be there, Joel's going to be there. Joel, by the way, is the manager of the Open edX team here at edX, and George, where's George? George is, he's sitting at the front. The guy that was checking you guys in, that's George Song. He's actually remote from Portland, but he's in town for a couple of weeks, and he's also a member of the team. The Open edX team, our goal is to enable and encourage the community to use Open edX, which, as you probably know, is the open source software that powers edX.org. So edX has a goal of teaching 1 billion people by some point in the future, and I'm hoping that half of those billion are on sites other than edX.org. Right now there's about 300 sites around the world that are doing online education using Open edX, which is very exciting because in addition to other high quality institutions like MIT and Harvard, there are all sorts of non-universities and companies and kindergartens and Pilates courses that are happening on Open edX around the world, stuff that we would never do as edX, but we can put the software out there and let 1,000 flowers bloom and do more education. So I'm very excited about that, as you can tell. What else do we want to say?
CFP.
There's a call for papers for the conference, which is open today as well. Is there a deadline for when that closes?
March 1st.
March 1st. So we have about 5 weeks to get proposals in for presentations that you'd like to give at the conference in Madrid. And we're interested in all sorts of topics. There's technical topics, there's course authoring topics, there's pedagogy topics, there's operational topics, there's how you make videos kind of topics. Anything that would help people do online education with Open edX is fair game for a talk. So if you have any inkling at all that it might be an interesting topic, make a proposal and we'll work it out and see if we can get you up in front of people in Madrid. That'll be very exciting. What else? Anything else? No. Okay. So the topic tonight is how MIT uses Open edX. And this is of interest to me personally because, as you may know, edX was founded by Harvard and MIT, so MIT had a big part of our starting, and MIT has courses on edX.org, but they also have people that write software for Open edX, and they also run courses online and on campus, and every once in a while I hear about another thing at MIT that's happening, and I thought, as well as you guys learning about it, if I could get Peter and Jolien here to come and talk about it, then I would learn about it, and so that's going to help me to understand the whole MIT landscape. You're going to tell us about it, right?
The whole MIT.
The whole MIT landscape. All of it. Yeah?
At least all that I know. As Ned mentioned, we are from MIT. I am Peter Pinch. I'm the Associate Director of Engineering at the MIT Office of Digital Learning, MIT ODL. And Jolien is one of our MITx Digital Learning Fellows in physics. And we're going to try to tell you everything that MIT is doing, not a chance. I'm hopefully going to be able to tell you a lot, and then you can follow up and ask me more stuff. So first of all, what is ODL? It's the Office of Digital Learning. We have a mission statement. The important words here are everywhere, digital, and education. So that includes on campus and across the world. I've got a wonderful org chart. In my experience, a new box gets added to this every 6 months. But there may be some familiar names here. And these are some of the groups that are using Open edX as part of the MIT Office of Digital Learning. You might have heard of MITx. That's the group that works on MOOCs. I've got a couple of folks from MITx here, if you want to talk to them about that. We also have what's called Mightily. That's the MIT Integrated Learning Initiative, and that's a group that's supporting research, fundamental research on learning, and as they do research and support projects on our digital learning, it's also being incorporated into new courses. So there's a cycle involved with that. We also have a group called the Digital Learning Lab. that folks like Jolien are part of. And these are scientists and learning fellows who are embedded in the departments at MIT and advocate and support the use of edX.org and OpenEdX in the individual departments. And because they're familiar with the content, they can really push the platform in new directions, which Jolien will do later. We also have a residential education group, and this is really our biggest user of OpenEdX. We run our own instances of OpenEdX on campus. Right now, about 90% of MIT undergraduates have taken at least one course or some content through OpenEdX. That's, I'm forgetting the exact number, but that's a couple thousand. So we're not contributing that much to Ned's goal, but it's an important part of the MIT experience. Not only is it a great learning platform, but it also helps faculty in a lot of cases teach more effectively and efficiently. OpenCourseWare, you might have heard of them. They just were celebrating their 15th anniversary. And since OpenCourseWare is representing the entire MIT curriculum, they actually bring in some of the content from OpenEdX on campus and convert it into their platform and distribute it with the open licenses and Creative Commons and all that good stuff. And then the last on this list is my group. We're the engineering part of the Office of Digital Learning. And we run OpenEdX on campus, so we have operational experience with OpenEdX. And then we also do software development, mostly centered on integration, but also some content and other things, which I will talk about. There's a lot of stuff that MIT does with OpenEdX. This was a sampling that I put together. And I'm trying to come up with some themes about the kinds of projects that we take on. They kind of fell into three groups. We've done some work on new assessments within the platform, filling in some gaps that were peculiar to our needs. This list is not comprehensive for sure, but these are some of the things that my engineering group has worked on, and I'll drill it down into a couple of these. We've also been very interested in content reuse. We've been running OpenEdX courses for, I can't count, almost 5 years now. So we have a tremendous amount of content, and trying to figure out the best way to find it and reuse it effectively is very important to us. And then of particular interest for my group is integration. So we run it on campus, we have to integrate with campus systems, things like grade books and authentication and publishing systems. So we spend a lot of time thinking about APIs and stuff like that. Just running through these really quickly, and I'm going to go into some more detail on these, but in the assessment space, we worked on staff grading. If we have time, I'd like to show you this sketch input assessment, which is really cool. It's developed by one of our, well, many folks in our math department. We've been doing a lot with exams on campus lately. In content reuse, one of our first projects was LaTeX to edX. How many people use LaTeX? There's more hands than I expected, actually. I don't count. There's a lot of LaTeX at MIT. And when you think about all the great teaching content, we want to be able to bring that onto edX and fit into that platform. CCX, which I'm going to talk about later, is custom courses on edX. It's a very lightweight approach to content reuse. And I'm not going to go into a lot of detail, but LORE is a more detailed learning object repository for education. It's a tool for finding and curating and cataloging edX resources. And then on the integration side, we've done a fair amount of work integrating edX workflows and authoring with Git. Again, maybe not something that most course authors want to do, but some of the advantages of version control and distributed authoring are really powerful. Another thing that I don't have a lot of time to talk about today, but I can take questions about, is our MicroMasters portal. It bridges the gap between the MicroMasters courses that we're delivering through edX.org and MIT's program in MicroMasters, and eventually leading into the master's degree. So there's a lot of exchange of information about which courses people passed and whether they're applying to which program and that kind of stuff. And we've written some libraries. We've done some work in LTI. And Jolene's going to talk about the Clickers project and maybe some other stuff. Yeah. So I thought I would drill down into staff graded assessments, because this is something that we've been working on for a long time and is still evolving. There's a brief history here of all the different ways in the history of edX you might have attempted staff grading. But one of the challenges with a MOOC is it's designed to grade a lot of people. But when you run a course on campus, you really want to be able to do the basic thing of submit a homework, review the homework, mark it up with a red pen, and give it back to the students. So that was something that was missing in the platform in the early days. edX, I think, like peer grading through ORA. So we wrote an XBlock called SGA, staff grade assessments. And then edX iterated on ORA, and then we iterated on the staff grade assessments XBlock. And then edX added staff grading to ORA. That was great, but it still wasn't everything that we wanted. So our latest version is what we call SGA LTI. This is my description of the original version of SGA. This is actually part of, it's an XBlock, but it's delivered along with OpenEdX now. So if you install OpenEdX, you get this XBlock. It's not turned on by default, so you have to turn it on. And basically, as I said, students upload a file, the instructor can download it, mark it up, and upload it, and set a grade. In the current state of affairs in ORA 2 with staff grading, we ran into a couple of issues that weren't working for us. The ORA grading workflow is the same as peer grading workflows. So there's a list of submissions, and the staff person gets one item, and they get to grade it, and they put it back and send the grade back to the student. And then they take the next one off and they send it back to the student. We had a course team where they wanted to be able to look at all the submissions at the same time and download them all and be able to compare them to each other so that the grading is consistent. Another thing about ORA is you can't respond with a file. In our case, again, we had, this is actually a philosophy course. We have philosophy courses at MIT. And they wanted to be able to download the assignment and then mark it up and comment on it and then deliver it back to the student. So again, there was like this two-way flow. And then something that's a little bit more of a serious issue for the platform, and something that we'd really like to do some work on, is having a way for some people in the platform to be able to do grading who aren't staff. So right now in Open edX, you basically have students or learners and staff. And then there's like an admin role that's a little bit more advanced than that. But the challenge is that the same people who are doing the grading and reviewing student submissions also can change the course. And that is not ideal for us. So we wanted to have a way to be able to segregate those two groups. Being MIT, we refer to those people as human graders. We thought about trying to enhance our X block, but that was going to be a lot of work because of this, particularly this issue about access control. So we decided to use LTI, which I don't know if everyone's familiar with, but it's a great standard for integrating educational systems, and it's a very nice way to extend edX. It's basically a way that you can run an application anywhere on the internet and embed it in your edX course, or other LMSs for that matter. It's a standard. It'll send grade, you can have grades sent back from this application as well. So we just put it off on another server. We get to make up our own access controls at that point. And I think I have some screenshots here, but I could actually try to show this. That work? No, it went all black. There we go. Real quick, there's a student view, there's a button where you can upload a file. I have some legal notices that I've uploaded here. And then there's a staff view where you can quickly see everybody who uploaded files and see their status. And we also had a distributed system because we thought we'd have like a lead grader and then multiple other graders, and there'd be a way for the lead grader to look over the shoulder of these part-time philosophers who are going to do the grading. It worked very well. There weren't that many students in the course, but it was very effective, and the ones that took it were happy, as well as the graders. So we did that this summer. Let's see if I can get the presentation going back again. The timer started over. That's too bad. I guess I'll have to talk that long. Let me talk a little bit about content reuse. So as I mentioned before, a lot of our content reuse originally was focused on reusing content from other formats. We had a lot of projects with a 2 in the middle. There was the mentioned LaTeX to edX. We have an OpenCourseWare translator that sort of works. There was even a Moodle translator, but I've kind of disowned that at this point. I should mention though that all our projects are open source. If they're all on GitHub, some of them are maintained better than others, but I'd be happy to talk about any of them. We spent a fair amount of time in our first year or two working on how to move course content around from Git repositories. When we started, that was the only way to write a course. Studio's made things a lot easier now, but it's still useful to be able to do that. And some of our more recent projects have been kind of on a spectrum, and I have a problem with I have to hold the microphone. So when you think about content reuse, I think of it on a spectrum of In some cases, you want something that's really dead simple. You just want to take your course and let somebody else use it, let somebody else run it. You're working with the whole course, you want a push-button solution. And at the other end, you have advanced authors who are trying to do things like find the best single problem that has been written in edX on Momentum and integrate it and drop it into a larger course that they're writing. So some of our content reuse is people who are just trying to deliver a course, and some of it is people who are trying to really author a course. And these two projects are at the opposite ends of that spectrum. CCX is designed to make it very simple, and Lore is designed for people who are course authors. This last one here is actually part of the edX platform, and I just mentioned it so that you know that it exists. There's a feature called Content Libraries in edX, when it's integrated with Studio, and it lets you reuse content, although right now it's limited in the way that you can reuse it. It's basically designed for things like a quiz pool, or a pool of questions that you would use in a quiz, and it pulls them randomly. The technology is there to do other things, but that's the only one that's been implemented. So I want to talk a little bit more in depth about CCX. This is something that we've been working on for a few years now. And it started with this fact that 30+% of our learners for the MIT and Harvard MOOCs specifically identify themselves as teachers. And we get a lot of questions from them of, how can I use this great content in my own teaching? It sounds like an easy concept, especially because the MOOCs are open registration. But when you actually try to take a MOOC and try to integrate it with an actual course that someone's teaching, like a blended course, there's a lot of hurdles to that. MIT's schedule is pretty aggressive. If you've seen how much we try to teach in 12 weeks. Not to mention the fact that most of our courses are 12 weeks. In a lot of cases, the content isn't scoped the way other teachers would want it to be. We cover a lot more stuff, or we cover different stuff than they would want. If you think about an open enrollment MOOC, a teacher who's teaching a face-to-face class can't actually control who has access to it. Or maybe more importantly, they would want to have a discussion forum in the course, but limit it just to their students. And there's no way to do that in an open enrollment MOOC. The teachers can't see the grades, only MIT can see the grades. And licensing is a big question. Still is, but CCX has given us a framework for how we might handle that. CCX has been in development for a while, but I think it was part of the Dogwood release. It does require that you split Mongo, that's an operational detail. In a custom course, we introduced a new role of a coach, a course coach. I gotta be honest, there's still some mixed feelings about whether that's a good label to use. But the idea is this is the person who's going to deliver the course, the custom course to the students. And the coach has control over a number of different elements of the course. They can control who can access it. They can control the schedule. So you can take an MIT course and slow it way down, if that's what you want to do, and spread it out over time. The coach can also access the grades, so they can keep track of how their students are performing, and the grading policy. Something to note here is there's been some recent enhancements to custom courses that actually wasn't implemented by MIT. It was done by Davidson College and OpenCraft. and they tied in a bunch of the other features of the instructor panel. So things like rescoring students and limited access to analytics and things like that. But some important things, the coach can't alter the content. So remember, we're at the end of the spectrum where it's just a delivery. The reuse is more of a delivery than an authoring. So we don't let the coaches actually change the content, and that actually has made the licensing concept easier for folks, because they don't have to worry about the original authors aren't less concerned about their material being remixed. And there are also some size limits. You know, we don't want people creating another course the same size as the original MOOC. So I'm going to see if I can flip over again to my browser. That's not the right tab. So, right now, this is the coach view of 700X. It's the Eric Lander introductory biology course that MIT's been running for many years. And right now I'm logged in as a coach. So I'm someone who maybe took the MOOC and said, I'd really like to use some of this with my AP Bio students. And I've made an arrangement with MIT to allow me to do this. And I now have a tab here called Coach that's available to me. And when I click on that, I get more tabs. Just basically 4 simple tabs here. I can control who is enrolled in my course, so I can add people by email address, or I can have a list here of who actually has access to my custom course. And I also have this schedule where I can build up a course by just using the elements that I want from the original Eric Lander course. So, show you. So the original course has more than a dozen modules to it. You know, these were roughly weeks in the original presentation. Huge amount of content. And I can actually just pick out the things that I want. I can choose them by section. I can also, the very exciting exam, I don't know why I picked that. Let's try something else here. And you can actually drill down to the level of a unit and take out the actual unit that you want. And then add it to the schedule. And there's just a simple tree here of all the things that I've added. And I also have the opportunity to change the dates. So this is actually right now a lot of the default dates, because this course was actually originally delivered in 2015. But I can change those to anything that makes sense for my students. And then we also have a very simple access to the student gradebook. And then for advanced users, you can modify the grading policy. And I mentioned that the instructor dashboard is still available. And then when one of my students logs in, you know, they have my custom course, and instead of this list that originally went down to here of content, it's just the stuff that's been assigned by my instructor, my coach. So MIT's used this with maybe a dozen custom courses. Actually, it might be closer to 2 dozen now. Particularly some of the entrepreneurship courses have been used a number of times this way. Actually, the biggest user of this technology has been Davidson College, which is up to, like, I think 500 or 600 custom courses at this point. They wrote a number of courses designed for AP topics in high school, and they've worked with a very large number of high schools to get those distributed. Berkeley has also used it with their computer science courses. So that's one of the ways we're looking at content reuse. And I think those are the things I wanted to highlight. I'm going to hand it over to Jolien. Should I pause for questions?
Yeah, let's do some questions now, people.
Okay, sure. Anyone? Yeah.
So can anyone get access to CCX?
So the tool is part of the platform. It's been in OpenEdX. The content requires some kind of relationship with the content owner. We've been working on something that we were hoping would sort of streamline the licensing process and like build a catalog of courses that were available, but that isn't ready yet. So it's still a little ad hoc in that way. But courses like biology, a couple physics courses, and in particular the entrepreneurship courses have been licensed a number of times this way.
And is it just the MIT content that's available to it now?
Besides Davidson and Berkeley, I don't know anyone else who's doing it, and their approach has been a little different. They've been more focused on like large-scale funded research as opposed to licensing. But we've talked to some other places. We've talked to a number of people. It's just been trying to get some of the things off the ground.
Yeah, so when you have residential courses like your philosophy course, right? Was that running in parallel with a normal kind of, chalk and talk or whatever you?
Yeah, we have a lot of variety, and we really leave it up to the faculty to decide how best they want to use the online courses. So we have a number of courses that are mostly interested in the assessments, and they've moved problem sets and weekly assessments onto the platform. And those are popular with students because they get instant feedback. There are some other courses where they've taken more of a flipped classroom kind of approach, and the emphasis is on the video. So students will use the platform to watch a lecture, and then when they go to the class meeting time, they actually do more project-based work instead of spending that time in a lecture. And there are other there's a wide gamut of how it's been used. So sometimes, like only a module from a course will be put online as a way to let people spend more time with a particular topic than they might be able to spend in the classroom. And there's a few courses that have experimented with going completely online.
Yeah, I'm also interested in what kind of comparative metrics you have for, the effectiveness of using this versus the sort of more traditional methods.
I don't know off the top of my head. Do you have anything that you would say about that?
There are some groups that are setting up courses to construct research education, but to actually get a metric between how well the students do in this versus that
Right, yeah.
is very difficult if you do.
Well, and also, satisfaction,
In
sort of like.
terms of student satisfaction, we do measure a lot. Students generally love having the material in the OpenEdX platform.
And I would say another thing that we have that is kind of, I think, unique to the edX platform too, is that we have courses that sometimes start as a residential to ramp up to go into a MOOC. So that's kind of it can kind of be like a launching board for them to get the class ready and try and run it residentially. And then when they have something more stable, then they can throw it to them.
And we've had a couple go the other way.
The
too.
couple go the other way too, yeah.
We test out the online material globally and then show it to the MIT students. And I mean, not the most exciting metrics necessarily, but there's also been a lot of use of the online platforms to automate and make more efficient some of this tasks like grading and things like that. So we've had a couple of courses where they've moved the quizzes and periodic assessments and even a final exam onto the
graders.
platform. And things like code graders too, in computer science. And that's made it possible for them to be a lot faster in grading and be able to get students feedback faster than they would otherwise.
What code grades do you have available?
We've
Python.
Yeah, so the introductory computer science courses use the Python code graders, so that's the same as, I'm forgetting the numbering now, but 601X and 602X. We also use MATLAB, and that's been on MOOCs and also residential. And people talk about more exotic things, but I haven't seen any implementations yet for us. There's a number of other code graders in the community, but we haven't used any others.
Thanks.
If anybody knows a good grader for optimization problems, like advanced Excel spreadsheets, that's something that we're looking for.
Can you talk a little bit about the analytics that course teams do at MIT on Open edX hosted courses, and how much of that is built-in edX analytics and how much is homegrown stuff from MIT?
Yeah, that's, I can't talk about that in too much depth, but we've had, and maybe you can chime in here if you know more, but we've had a project sort of informally called X Analytics that has been somewhat parallel to edX Insights. So covering some of the same ground, but focused a little differently on some of the measurements and processes that we were interested in. And frankly, also, I think we invested time in that so that we could also, for lack of a better phrase, double check edX's results so that we have an independent assessment of the outcomes. So we ingest all of the tracking logs that the raw data that edX generates, and then run it through this X Analytics system. We use Google BigQuery for the analysis of it, and that might be all I can say accurately.
Is X Analytics open source?
It is. I'm not sure how easy it is to use out of the box, but I can also put you in touch with some people that would be able to speak more about it. And we collaborate also a lot with Harvard on that too.
Did edX get the data right, insights?
Close enough. I mean, there's been some conversations, but yeah, I mean, it's never exactly the same when you're doing something like that, but it's in the right ballpark, for sure. Yeah.
So, when the faculty want to use it, is the platform up and running, and of course, like how do they use it, the on-campus faculty, and what kind of training do they have to have, or do they just train themselves, that kind of thing?
MIT faculty are a unique bunch, and we've been working with really a lot of the early adopter types, and they've also been the kind of folks who really push the platform, and the flexibility of edX has been very appealing to them. And I think one of the things that we're trying to figure out now is how to expand the use of the platform outside of those early adopters. We do some outreach and some training. We rely on the edX documentation a lot, which is great. And we're starting to make some investments in the instructional design side of it, but that's been actually a new endeavor for us. So it's been a learning experience. And really one of the biggest ways has been our use of these digital learning scientists and fellows like Jolene, who are established in the subject matter and figure out how to adapt the platform in a way that makes sense to any particular department. And I'm going to use that as a segue. I'll be around for more questions after. If there's anything else. Oh.
Maybe it worked before. It did work before. There it is. All good. Okay, one day I'll learn how to make a 9x16 PowerPoint. So, with that introduction, my name's Jolien. I'm a physicist at heart. I tend to spend a lot more time doing computer programming nowadays, but that comes with the job, I guess. And I've been involved with teaching in the physics department for the past 4 years, I guess. And a major part of that teaching has been using the OpenEdX platform to advance our residential courses to enhance the student experience and student satisfaction, and to optimize the use of instructor time and resources. So what I want to do today is to give you a kind of scattershot approach to different things that we've been using the edX platform to do. This is a little bit incoherent, but I tried to cram as much as I could. Most of the edX platform use in physics has been in the very introductory courses, 801 and 802. These are courses that basically every MIT student has to take and pass. And we range from 500 to 750 students in these courses. So putting together a set of resources and a set of instructors and getting all the professors together and so on to get these courses running is somewhat of a large endeavour, and getting as much of it automated as possible is one of the goals that we've had. These courses are taught using the technology-enhanced active learning approach. We've got a lovely big classroom that we use with a lot of open space and whiteboards on every wall and lots of projectors and stuff like that. So it's quite fun to teach in that learning environment. And as I'm hinting, we, in the past few years, have been steadily using edX more and more heavily. The first time we used edX for teaching these courses, we said, right, we're going to do them a little bit, just we're going to put our problem sets online, and that will be it, no more. And from there, we built up to the edX page is our one-stop shop for absolutely everything in the course, and we've even developed instructor tools that go on top of that edX course to try and help the people who are teaching in front of the whiteboard. So, starting at the beginning then, the obvious thing to use edX for is automated assessment. And we typically use a variety of different assessment types on the edX platform. Each week in these courses, we've got some reading questions for students to do. These are your multiple choice, check the boxes, or very simple calculation type things, where students give it a couple of goes. If they still don't get it, we show them the answer, and we've used these to basically replace readings and reading questions that our data shows that students weren't actually doing. And we found that by turning it to an interactive environment that's on the computer, rather than having them to write something and read textbooks and do things they don't want to do, we get significantly higher student involvement with these question types. We also have Friday problem solvings, which is basically our recitation sections, where we've moved towards taking all of our problems that we were doing in those problem solving sessions and putting them on the platform. So students can check their answers as they go, and they know when they've gotten something right before moving on to the next part. And even more so here, we've been able to use the platform to say, whoops, looks like you got that wrong. Perhaps you'd like to look at this resource, which kind of explains what's going on here. And my favourite story here is that we've been recording some videos targeted at difficult aspects of some of the problems that we do in these problem-solving sessions, so that as soon as students hit that bump where we've identified a priori that there's going to be problems here, we've given them a 2-minute video to say, right, now you've seen this, how do you do it? We've got your attention, let's go through it and discuss it, so then you can apply it. And my favourite anecdote here is one of the people who recorded some of these videos was teaching the class one day, and he walked up to a group and he said, right, oh, how are you going? Do you need any help? And they said, oh no, we don't need you. We're watching a video of you. We also have problem sets that are due on a different day, where these are the problems that really bring the material together, and we really want students to grapple with it. And for these, we want students to actually write up their solutions and hand them in, so we can give them feedback on their problem-solving strategies and approaches, not just on whether or not they got the answer right. But we do let the students check to see if they've got their answer right. And this has been a great motivator for students who can tell when they're done with a problem set, or if they need to think about it a little bit more. And this has proved very popular. If you've ever sent a survey to undergraduate students on anything, you will be impressed to hear that the immediate feedback on problem set problems has a 96% approval rating, and it's almost impossible to get that type of approval rating on anything from undergraduates. Okay, so this is the stuff that you could do with edX out of the box. What I'd like to move into is what can you do when you start pushing the boundaries of edX a little bit, and what are some of the things that we've tried to implement. Okay, so I've touched on this one already. We can give instant responses in the classroom. So we've been using this in our problem-solving sessions. We've also been using this for things like experiments in class, where instead of having students work their way through an experiment on paper and do their calculations and get to the end and have no idea whether the wavelength of that laser is 600 nanometers or 600 kilometers, we can actually give them some feedback along the way as to how they're going. So some of this requires a little bit of technology. We can do some contextual parsing of what the students have put in box A and box B, and if we multiply them together in the right way, we can check that what they put in for box C actually makes sense or not. So this allows us to really give some targeted feedback to students on how they're going and where they might have started going wrong. So here is an example of how we've used this in experiments, where this is a diffraction experiment where we've got a laser and a diffraction grating, and students make a few measurements, and by computing an appropriate quantity, they can calculate the wavelength of the laser. So here they made a reasonable measurement for a length, another reasonable measurement for a different length, that both were checked as, did your numbers fall within reasonable ranges? And then we said, right, did you divide these two numbers and get the units right, and multiply it by the appropriate constant to find the answer that you actually want. Moving beyond the immediate capabilities of the edX platform, I'm going to talk a lot about exploiting the mighty iframe. For those who don't know, an iframe is basically a website within a website. And so you can take a website and put it in a edX vertical, and it looks like it's just part of your website or the edX webpage, assuming you've styled it correctly. And I'm going to talk about 3 different ways that we've used iframes within our residential teaching to our advantage. The first one is Google Forms. edX is a lovely platform for doing grading and that type of stuff, but it can be a real pain if you want to extract the data from it that students put in quickly. And sometimes you just want a quick solution to give a survey, or you want anonymous feedback, or you want a variety of simple things where students enter a form, press submit, and it gets emailed to you or something like that. And so you can very straightforwardly embed a Google form that dumps its data in a spreadsheet and is very easy to get the data out of. And we've used this for anonymous feedback, conflict exam requests, excused absence spreadsheets, surveys, and a few other things. It's just a quick way to extend the capabilities of edX. The one thing that using a iframe to embed a form like this loses is that that form has no idea who the student is, what course they're in, or any of that type of information. So it's mostly anonymous information that goes into here. It has absolutely no access to who is this student and where have they come from. If you want to start getting into who is this student and where do they come from, you need to start using the LTI tool that Pete talked about a little bit. LTI stands for Learning Tools Interoperability, and is a standard for how to communicate between embedded modules, in a sense. Basically, an LTI component is a website that you have set up on a different server, that's not edX, that gets embedded in your page, and that website gets 2 bits of information. First, it gets the course that it came from, and second, it gets a anonymized student ID. And if you're at MIT, then there's a few tricks that you can play to actually get the student username so that you can actually figure out who's who. The benefit of working with LTI is that you have a complete web server at your disposal. And if you can code it in Python or PHP or HTML or JavaScript or whatever you want to do, you can make it work with an LTI component. There are a couple of quirks to LTI, one of which is that Safari has draconian security settings by default for LTI, so a bunch of LTI stuff doesn't work if you use cookies in Safari, and we haven't figured out a way around that, unfortunately. So one thing that we've used LTI for is to enhance our usage of the Humble Clicker in our classrooms. So we use these rapid response devices to get student feedback, instant student feedback to questions within a class. And these are great for instructors to see, to poll the class and see what the students are thinking and kind of where they're at. At some point in time, if you want to actually do anything with that data that the students are generating, you need the students to register their clicker, and that's where our LTI comes in. Once students have logged into MITx, we know who they are already, or at least we can get that, and we might as well let them register their clicker, and we can ask them for a little bit more information, like, okay, what class are you attending, and what table are you sitting at, and what's your group number within that table, and then we can start doing some fun things with that data. So, as I mentioned, these were 500 to 800 student classes. You can imagine the level of support that we get from MIT for divvying these students up into groups and so on. Not much. But once students have registered, then we can actually go and generate useful class lists for the teachers of the individual sections. So here's an example where we have 3 students in table 2, a couple of groups at table 3, and we can just go and generate these things. On the flip side, we can also, take back that clicker data that we've generated and then pass it as we will and push grades back into the edX platform if we want to. The other fun thing that we've been able to use LTI to do is to track student progress through a class in real time. So for a normal course, after the course is finished, you can go back and look at the clickstream log and see where the students have actually clicked through and what order they've gone through things. But we really wanted to get real-time information on how students are progressing through a given exercise in a class. So what we've done is, for a given exercise, put in a dial home LTI component just at the bottom of the vertical, and kind of make it as unobtrusive as possible. And this just says, this just pings home every time that vertical loads and says, student is currently at this place. And when we use this in conjunction with conditional X blocks, this allows us to, well, I guess I should explain a conditional X block, where we can say you have to answer all the problems on this vertical correctly before you can move to the next one. So we can use this to figure out which vertical the students are currently working on, and thus track their progress through the exercise in class. And at the end of the exercise, we've got a server that's got information on all of the students and how far they got through that exercise. And if we want to, we can then push grades back to some landing page in the edX platform to say this is how far the students actually got through this exercise. And one of the benefits of doing this is that we can actually implement group work where multiple students in a course are only working at one person's login. And because we can push the grades back, the grades go back to all of the students who are involved in that group. So we use this for in-class experiments where students form groups, they work through the experiments one vertical at a time, and it's useful to know what the student progress is through those through the experiments, and then to be able to upload student grades based on how far they got through that work. So here's an example of an experiment where we've got, I guess, 4 verticals with things that students need to do, and the last one is basically a congratulations, you've finished. Here's some things that you might think about page. So the very first thing that students need to do is to log in and basically give us their usernames of everybody in their group. And I'm going to highlight again group, which is otherwise difficult to work with in edX. Here's an example of the little dial home component just embedded at the very bottom of the vertical. And as I said, we try to make it as unobtrusive as possible. If students haven't logged in, then this gives us a nice bright red flashing message saying you need to go and log in or you don't get credit. It's these little LTI components that dial home and continually update the server on the student progress. And then we can use that to do fun things like this, where we can say this is a map of our classroom. Each square represents a group of students, and we colour that square based on how far through that experiment that group has gotten. So a quick look at this, and I can say, well, I probably need to send one of my teaching assistants to table 1 because students are lagging a little bit there. You can always click on a group and find out who those students are, and actually surprise them by knowing their names when you go and say hi.
How do you know which student is with the city where? Do they all have to stay in the same place?
So it depends on how you set up the course. In this room, there are actually 3 computers at each table, and each computer has a static IP address, and we use that to figure out which table was which, or which group was which. Otherwise, if there's 9 students at a table at most, you'll be able to figure out who they are by looking at their pictures, hopefully. So, one point in time, I went and took a screenshot of this little map every 30 seconds while an experiment was running, and put it together in a little video. So let's see if I can get this to play. No. There we go. Okay, so here 1 second corresponds to 1 minute in class time. And this was a very full class, a lot of students here. Each square is usually 3 students, sometimes 2, sometimes 4. But this gives us a quick bird's eye view of how is progress going in our classroom right now. And instructors really love this capability. I think 1 more square goes. No, 2, okay. Very good. Okay, so the conclusions here are basically that the scaffolding for implementing a lot of technological services in the classroom are really becoming more and more present within the platform, and and even external to the platform. Most applications that you'd want for a classroom have some sort of technological implementation already. Some are straightforward to implement, some of them, okay, you might need to write from scratch, but most of the time it doesn't require a huge amount of tech know-how to get some of these things to work. And I'm going to particularly point to this last point of if you can use an iframe to make your life better, then give it a go, because they're really quite versatile. Okay, thank you, and I'll take any questions.
So a lot of the publishers, when it comes to physics, develop a lot of these online homework systems where the students go online, they do their homework, it's automatically graded. So is what you're doing replacing the online homework system, or are you still using those types of systems in conjunction with what you developed with edX?
We aren't using any online homework systems other than what we've put on edX at this stage.
Okay.
We've been a little careful about putting absolutely everything in this online system because I think that one of the important things in physics is the process by which you get to an answer, not just that you got the answer right. And so we do want students to actually generate written stuff so that we can give them feedback on that process. But for most intents and purposes, what publishers have put together, we can typically reproduce in the edX platform at this stage.
Okay.
Other questions? Probably under for Peter.
Yeah, I'd like to ask some more about this question about early adopters versus the potential for, mainstreaming something like this, and really putting it out. Because one of the sort of early statements about edX was that it was to help democratize education, right? Now, so, and to me, it's technology, early adopters, and use it till the cows come home. But if you can't really, scale it, use it in other venues, then you will, that's a goal that's going to be really, really tough to achieve. So, even inside MIT, right? If you have this kind of, segregation between people who go there and the others, how do you see that developing?
I should clarify, my statement about early adopters was more about on the faculty side.
Right.
On the student side, we've essentially gotten almost all the undergraduates at some point using this platform.
So you think it'll be a generational thing, or?
I think that's a part of it. There are a few MIT faculty members who still don't use email, for instance, surprising that may be. I think it's a question of also what tools are appropriate for the teaching material. And Jolien hinted at that a little bit, that even in an introductory physics course, there's some material that doesn't have a good analog online yet. The other thing that we need to do is continue developing the tools. One of the things I didn't show was the sketch input tool that our math department uses. So for their courses, a really fundamental thing is students being able to draw simple graphs to demonstrate that they understand the concepts in mathematical formulas. And that's not an easy thing to do necessarily on a website, but they've done some really creative stuff to be able to facilitate that and integrate it with the educational experience that they're looking for. I'm happy to show that too, but I don't want to take up too much time.
Other questions? Well, okay, I want to thank the speakers. We can hang out here until about 8 o'clock. There might be leftover food. There's some snacks and some drinks over there. There are a number of edX people here right now. Raise your hands if you work for edX. So all of these people, all of these people have strong opinions about the democratization of education and stuff like that. So we would be glad to talk to you about those ideas or any others. So stick around and meet people and whatever. Thanks a lot.